Hi, in this video I'm going to be showing you how to come up with the cosine rule using the chord theorem and also Thales' theorem. Now the chord theorem goes like so. You may have two chords inside a circle like this, and the segments are A, B, C and D. Okay, A and B form part of one line and C and D form part of the other line. And it turns out AB is equal to CD. So that's the chord theorem. Now Thales' theorem is if the diameter of a circle forms the hypotenuse of a right-angled triangle within that circle, like so, okay, then one of its angles that is touching the circumference is going to be 90 degrees. So in this case here, we have this right-angled triangle. This length here is the diameter of the circle, and up here we're going to have 90 degrees, and that's Thales' theorem. Okay, so let's prove the cosine rule. This angle over here is going to be called theta. This angle over here is pi over 2 radians because it's 90 degrees. This angle over here is going to be pi over 2 minus theta. Okay, the radius of this circle is going to be called A. So it means this length over here is A. This length over here is A. Now, if this length over here is C, that is from the center of this circle to over here, then this length over here is going to be A minus C. Okay? And what we're going to do is call the length over here B. So that's from here to here. Okay? And what you'll notice is that we have a triangle right over here, okay? And it's this triangle that we'll be using to prove the cosine rule, okay? So now we have all the ingredients we need to prove the cosine rule. Now the first step we're going to take is to write down cos theta, okay? And that's going to be the adjacent side of the large right-angled triangle over here over its hypotenuse, okay? And its hypotenuse is going to be 2a. Okay, now what that's going to mean is that the adjacent side of the large right-angled triangle is going to be 2a times cos theta, right? Because we multiplied both sides of this equation by 2a. Now, if the adjacent side of this right-angled triangle over here is 2a cos theta, then it means this length from here to over here is actually 2a cos theta minus b, okay? Because we have to subtract this b from the adjacent side. Now all we have to do to get the cosine rule is apply the chord theorem to this diagram over here, okay? So let's go and do that. It turns out that 2a cos theta minus b in brackets times b, okay, is going to be the same as a plus c, which is these two segments over here. So that's a plus c times a minus c, this segment over here. Okay, so all we've done here is apply that chord theorem to this diagram. We've multiplied this segment by this segment over here. So that's 2a cos theta minus b times b. And we made that equal to a plus c, this segment over here, times the segment a minus c. Okay, now let's rearrange the equation over here. Okay, so we're going to get 2ab times cos theta minus b squared, okay? Because we multiplied this by this and then we multiplied this by this. Okay, now that's going to be equal to a squared, okay, minus AC plus AC, which is equal to 0, minus C squared. Okay, now let's rearrange once again. We're going to send C squared to the other side of the equation, and we're going to send 2AB cos theta and minus B squared to the right-hand side of this equation. That's going to give us C squared is equal to A squared plus B squared minus 2AB cos theta. Okay, and it turns out that that is the cosine rule. Okay, so therefore C squared is equal to A squared plus B squared minus 2AB times cos theta. Okay, and we have our proof. And this over here is going to be related to this triangle over here that has been highlighted in red. This proof can be found inside the book Proofs Without Words. It's on page 32, and it was discovered by Sidney Kung. Okay, if you'd like to purchase this book, please visit the link to my Amazon store below this video. If you want more proofs like this, make sure you're subscribed to my YouTube channel. For more maths content, visit mathematics.proofs on Instagram. Thanks for watching this video, and see you next time.